Alright, so up top are actually the notes from class, and in case you didn't get them, I wanted to show you one more time because I know I went through quickly. It was just a review of the properties. So if you have that, we can keep going. If not, you can press pause right now. So what I'm going to do, hopefully, if I can get this to work, I'm going to go through this problem that I told you about in class. So starting off, I'm going to analyze starting with domain. So what we do is we look at the two functions that are being multiplied. So this guy here, that's got an odd root. It's a 1/3 power at the bottom, and that's an odd root, which means that piece, the domain, is all real numbers. And then there's also this piece, which is a domain of all real numbers. So this guy just has a nice domain of all real numbers. Secondly, I'm going to look at intercepts. And for my intercepts, I guess I'll look at my y-intercept first. I don't really care what order you go. So my y-intercept is where x is equal to 0, so I'm going to find f of 0, which would be -2 times 0 to any power is just 0, and then multiplied by -4 gives us 0. So the point 0, 0 will be on my curve. Then my x-intercept would be when the y value is 0, -2 x to the 2/3 times x minus 4. If I want to set them equal to 0, it's already written nicely, so I have two factors. So I get -2 x to the 2/3 is equal to 0, and then I get x minus 4 is also equal to 0. So x equals 0 here, and x equals 4, so I get the point 0, 0, which should make sense because that was the y-intercept. And then I get the point 4, 0. So I know those will be 2 points on the function. Moving up. So next, if I know my intercept, I'm going to look at asymptotes. And going back here real quick, looking at the function -2x, I'm going to rewrite the function here. Let's see. And let's change color. Oopsie. Oh my lord. Alright, so my asymptotes. I am going to get f of x is equal to -2 x to the 2/3 times x minus 4 was the function. Let me double check that real quick. Alright, I did copy it properly. Sorry if I'm making you dizzy. Alright, in terms of trying to find the asymptotes, in this case, I know for my vertical asymptote was easy. There's none because there's no denominator. As a result, I also know there are no removables. My horizontal asymptote is a little bit harder. I'm going to actually multiply out so I can find the highest power in the numerator. We end up with -2 x to the 5/3, and then that would actually be plus 8 x to the 2/3. And I just want to look at this guy. So what I want to see is that this is actually going to be, let's see, how can I explain it? Put a number, a very, very large number in for x, 1,000,000, and take it to the 5/3. It's going to get bigger, and then multiplied by a negative. So some of you were doing things like this, positive infinity to the 5/3. Well, this would be positive. The -2 would make it negative, so this is negative infinity. And then in a sense, we could also do this. Take a very negative number, take it to the 5/3 power. It's still going to be negative, and then multiply by -2 gives me positive infinity. So the limit as x goes to negative infinity, which is my end behavior, is positive infinity. And then the limit as x goes to positive infinity of f of x is negative infinity. So this is one way I saw a lot of students using to deal with end behavior, and it's a valid way. Next is symmetry. So let's see, let's change my color. Let's go green, I guess. Alright, so for symmetry, I'm checking if I take the function f of x and I actually substitute a negative x, what does that do to the function? So I get -2, the x would be to the 2/3 power times negative x minus 4. And all you're checking to see is if this will simplify back to the original, or if it will be the exact negative of the original function. So here's f of negative x. I'm actually going to write down what f of x was so you see what my goal is. My goal is to get this exact function to come back. So up here, take a negative, oopsie, let's move this up. Take a negative x squared, that'll make it positive, so we end up with negative 2 times x to the 2/3. So that actually goes back to what the original function was. The problem is this negative x minus 4. It's not exactly the opposite, and because it's not the opposite, this does not equal f of x, nor does it equal negative f of x. Oopsie, whoa, sorry guys. Whoa, sorry again. I just figured out why. Alright, so what that means is this definition up here would have been even, this definition would have been odd. This has no symmetry. At least not about the y-axis or the origin. So I believe that's everything for identifying all the information for f of x. So now I'm going to actually find, given my f of x function, negative 2 x to the 2/3 times x minus 4, I am going to find its derivative. And we're going to analyze the derivative. So leave the first one alone, multiply by the derivative of the second, plus, here's the second function, multiply by the derivative of the first, and I'm going to multiply this power right here, and I get negative 4/3, and then x to the negative 1/3. In this case, I'm going to simplify as much as possible, so negative x to the 2/3. So the negative 4 and the x plus 4 will stay in the numerator, or sorry, x minus 4, I'm sorry. The 3 will be in the denominator along with the x to the 1/3. And then to get my common denominator, I'm going to first see, does this 3 cancel? It does not. So my common denominator would be if I multiply this guy by this whole denominator. So 3x to the 1/3 over 3x to the 1/3. Alright, so now that I have that, I will be getting, it looks like negative 6x plus negative 4x plus 16 all over my common denominator of 3x to the 1/3. So what do we get? We get negative 10x plus 16 all over 3x to the 1/3. And I guess I could factor out a 2, which would give me negative 5x plus 8 all over 3x to the 1/3. So I'm going to actually go ahead and analyze the function. So, like I said, these are extremely long problems. I know that. That's why you only have a few to do. So I'm going to take my first derivative. I'm going to set it equal to 0. And that would be negative 5x plus 8 multiplied by 2 equal to 0. So x is equal to positive 8/5. That'll be negative divided by negative 5. F prime equal to undefined. I would get at 3x to the 1/3 equals 0. X equals 0. And this should actually make sense. Let's go back to the original function. See? Not exactly sure what I did there. Sorry guys. Alright, so one more time. The original function here, that actually has a 2/3 power. So in your mind you should be thinking there's a cusp. This is where the cusp is coming from. And if you remember back to when we found their intercepts, the cusp actually happens at 0, 0. Okay? Alright, next, sign chart for this guy. And I am going to go back and do a sign chart for f in a second. I'm going to actually kind of put all the sign charts together. Alright, so we were undefined here, we were 0 here, the domain was all real numbers, so nothing is crossed out. I'm going to pick a very, very negative number, and I'll be doing my sign chart using the original right here. And so, some of you get a little bit confused by this, negative 2, x to the 2/3 times x minus 4. So what does this mean? It means that this little piece right here is always positive. So I can literally do my sign chart using negative 2 times x minus 4. So if I put in a very negative number, negative 1 million times negative 2 would be positive. In between here would be 1, which would be negative times negative, which would be positive. And then over here, we end up with, did I do that right? I feel like I might have done something wrong here. 1. Okay, well that makes sense because that's an even power up top. Duh. Alright, and then positive 1 million times a negative would give me a negative right here. So that's my first derivative sign chart. This tells me we're increasing, this tells me we're increasing, this tells me we're decreasing, and we knew that there was a cusp here. Let's see. Sorry, I'm just thinking to myself here. Oh! I know where my mistake is. Wow. Hopefully you found it, because I could keep telling that I analyzed this thing wrong and I couldn't figure out why. So, let's go back. Erase these guys. What I did wrong, which is often a mistake, I substituted not into the derivative, I substituted back into the original because I was thinking about what I said about making a sign chart for the original. My bad. So there is the function I'm substituting into, which will completely change the sign chart. Alright, so let's put in negative 1 million. Negative times a negative would make this part positive, divided by a negative, so that would be negative. 1 would be the number I'm picking, that would be positive, so positive. And then a million would make this top very negative, and then this bottom very positive, so that would be negative. That makes much more sense. Okay, now that we have that, we're decreasing, we're increasing, and then we're decreasing again. So that's pretty much everything I know about f prime. Then I want to go and do f double prime. So let's go back and make sure I have my f double prime. Well, first let's start by writing out f prime. So if you remember, f prime of x was the 2 times negative 5x plus 8 all over 3x to the 1/3, and that's if I didn't make any mistakes. I'm actually going to multiply the numerator back out, and the reason I'm doing that is because it actually makes it easier to find the derivative. So when I do my second derivative, I'll do a quotient rule. Okay, so low, d of high minus high, this is going to be ugly, just warning you all, d of low all over low squared. So this forces us to look at a lot of algebra, which is probably good for many of you. So first thing here, I'm going to multiply that, and I get negative 30x to the 1/3. Here, because of this minus, I'm actually going to distribute my minus to this term. I'm going to get positive 10x plus, or sorry, minus 16. And then multiply it by x to the negative 2/3. And then this is all over 9x to the 2/3. Now here I have a negative exponent, so I don't want to have the negative exponent, so I'm going to have to create a denominator. Let's do that here. So my beginning term, Lord, I hope I have no mistakes here. My beginning term plus 10x minus 16 all over x to the 2/3, and then this is all over 9x to the 2/3. My common denominator here would be x to the 2/3. So I'm going to multiply the first term, this one, by x to the 2/3 over x to the 2/3. So we get negative 30 times x plus 10x minus 16 all over x to the 2/3. And then we're dividing by 9x to the 2/3, so I'm going to actually multiply by 1 over 9x to the 2/3. So we get negative 20x, see, in case you guys can't see, push this up, minus 16 all over, if you multiply these, you add the powers, so I get 9x to the 4/3. So it actually looks a lot nicer, and remember this was the double prime. So I'm going to set my double prime equal to 0, which would give me negative 20x minus 16 equals 0. X is equal to positive 16 over negative 20, which simplifies to negative 4/5. I want my second derivative equal to undefined, which would be 9x to the 4/3 equals 0. X equals 0. That should make sense. Remember, that was our intercept, and that was our cusp. So this is what I mean by kind of putting everything together. Alright, so we have all this done. Now we're going to do our second derivative sign chart. And we have negative 4/5. See? We have 0. At 0 we were undefined, negative 4/5 we were 0. I am substituting into this term here. And here's one where I hopefully we'll do this correctly this time. The denominator is always positive, so we get to ignore it. The whole entire denominator is always positive, so I ignore the whole entire thing. This happens to be a line with a negative slope. Goes like this down your graph. I hope you can kind of see that point. So if it looks like this, then you know your signs are plus, minus, oopsie, goodness. This thing moves like crazy, sorry. Minus, minus. What does that tell us? Tells us that this is concave up, this is concave down, this is concave down, and this right here is a point of inflection. Now the only thing I'm missing is actually the F sign chart, so I'm going to go back up, see if we can find our F function that we did. Look at all this work, it's crazy, isn't it? So, here was our F function at the very beginning of all our work. And what I want to do is look at what values you need to create an F sign chart. So I'm going to do that here. Pretty much exactly the same exact values wherever F is 0. So, F of x equaling 0 is right here. We found it right there. So that'd be 0. And wherever f of x equals undefined. In this case, we don't have any undefined values. So the F sign chart is pretty basic. If you have a negative number, this piece, regardless of what value you put in, gets squared, so it'll always be positive. So I have a negative 2 times a negative number, which would make it positive. And then a million would be a negative number times a positive number, so that would be negative. So what does this tell me? This is above the x-axis, this is below the x-axis. So now I'm just going to put literally everything together. Alright, so let's see if I can do this properly. Alright, so what I did here was I actually went and grabbed all the sign charts that we created and put them into one. And then I'm actually going to add in from the very beginning, so I'll scroll up for you. I'm going to add in the other point we found, which was 4, 0. And that was an x-intercept. So actually, I just realized that I missed, let's see, a 0. That was one of our zeros, and I did not find that value. So that could have caused me to get a wrong value for our sign chart, and I believe I did. So if I put in 2 here, I would actually get positive, but then if I put in a million, I would get a negative. And that's what happens when you find one value missing off your sign chart. So this is above the x-axis and this is below. If you're wondering about that, I just fixed it. So now what I'm going to do is come back down to my sign chart. I'm going to fix this piece. So this actually was plus. All the way out here would be 4. That was 0. And there was a minus. This was above the x-axis, and this is right here below. So it's a little bit ugly. I'm going to rewrite a few things. I have the point 0, 0. I know I have the point 4, 0 on the curve. I'm just going to create a graph now using all this information. So, let's see. So, I actually made it a little smaller so I have a little more space to write. And then now all I'm doing is making a graph. So here's my y-axis, here's my x-axis. I need some values on here. So I know, it seems kind of pointless. You make all that information and in the end you make a simple little graph. I know, but it is part of the work. 1, 2, 3, 4. So here's my point. And then from now on, you really are just using all this information. Now, for some of you, what really might help, you see these other x values, 8/5, -4/5. You could use those to find the y values, and then you would have exact points also. So, how do you put all of this together? Well, -4/5 would be like right around here, so just kind of keep that in mind. You start off, in my opinion, the easiest way is to kind of break up your graph so that you know what you're supposed to be graphing. So I'm going to graph close to 0 because that's an easy place to go. I know after I'm going to be above the x-axis. I know I'm going to be increasing and concave down. So let's just kind of draw what that looks like. And I'm going to do this in a different color. Alright, so what does that actually look like? So right now, I'm going to use this part right here. I'm just going to draw what that looks like. And if you need a little help, I want to be concave down. So that's this part, but I have to be increasing. So that's this piece. At 8/5, I'm going to change. I'm still going to be concave down, but I'm going to decrease. Alright, and that's right until 4. And after 4 it still happens, but the difference is I just hit a 0 on the graph. In between 0 and -4/5, I'm concave down and decreasing, which we already did. And then before -4/5, I'm concave up, and I'm still decreasing. So concave up, but decreasing would be this half. Let's see. Alright, so let's just double check. Concave up, decreasing. Concave down, decreasing. Concave down and increasing. Concave down and decreasing. And then I just got to put that into my graph. So what's easiest is pretty much, let's see, from here I got to go up. And then I got to decrease at 8/5, which would be about here. So back down. I got to hit the 0 and keep going. Not the prettiest graph. And then I have to make this and then that. So my point of concavity changing has to be about here. I'm concave down here, but here I have to be concave up. So let me actually change that a little bit. So there's a point of concavity right here, but what you'll notice is it didn't affect my first derivative. I'm still decreasing till I get to the point here, then I bounce up and come around. So then the other questions I get are, how do you know your graph is really that accurate? Well, you find values. So remember x equals 8/5. Well, I would find f of 8/5, which would be -2x to the 2/3 times 8/5 minus 4. So what you'll see is, because the values are not pretty, I have elected to not force you to find all your y values. So on here, I did not put any y values, but I double check my graph. And how you double check it, you check piece by piece. So you don't do all the pieces together, you just check your f double prime. So I should be concave up, concave down, and still concave down. My increasing, decreasing, I should decrease, increase, and then decrease. And then here, and so this is, the maximum is occurring at x equal to 8/5. This point of inflection happened at negative 4/5. And then the F graph sign chart would be above to here, and then below. So there's my graph. This was an extremely long video. You're welcome to skip through the pieces that you didn't need. Hopefully this helps. Wow, 25 minutes.